6 test. First one is convert pi square root of 3 radians to degrees in decimal. So if this is radians, pi square root of 3, then I have to multiply by something that will cancel the radians, which would be pi radians and 180 degrees. Same size 1, so the radians would cancel here, so and the pi's cancel. So I'm going to get square root of 3 times 180, which is 311 point. Now, the question is, how many of these decimal places do I want to keep? Well, if I'm going to go to degrees, minutes, and seconds, I'm going to have a couple decimal places, and the thing. So I need, like 6 digits of accuracy. I should keep at least 4 of these decimals. I'm going to keep at least that much. I'm going to have 7691. Now, to convert that to degrees, minutes, and seconds, there's 311 degrees. I do not put that decimal because I'm changing the decimal part to minutes. So I subtract the 311, and now I've got this decimal that I want to find out how much of a degree that is. So I'm going to multiply by 60, and I get 46 minutes. I don't keep any of that decimal because I'm going to get that in the seconds. So I subtract the 46 and times that by 60, and I get 8.9, or 9. So that's 2 points each, 4 points total on that problem. Over here, I got to convert degrees, minutes, and seconds to degrees in decimal. So I got to take 32 degrees plus 33 divided by 60, because there's 60 minutes in an hour, 60 minutes in a degree, plus 24 divided by 60 times 60, which is 3,600, not 360 like some people did. And that's 32.55666, repeating, degrees in decimal. Now to convert that to radians, I got to take that answer times, I got to get the degrees to cancel, so I want 180 in the denominator and pi in the numerator times the 32.5566. Actually, I should round that off to 7. So I take this answer times pi divided by 180, and I get 0.568221 radians, keeping about 6 decimal places. All right. Next problem is just, can you remember those special angles? I know we have that special angle quiz that I'm requiring you to pass, but now you're just saying square root of 2, and that square root ends there. Some of you may not have read it that way. So it's the square root of 2 tangent of 30. So if I go to the unit circle and go to 30, the tangent's the y over the x, that's a half over the square root of 3 over 2, which is 1 over the square root of 3. So I got square root of 2 over the square root of 3 out of that. And then I got to go to 7 pi over 6, 7 30s. There's 3 30s, 6 30s, and 30 degree down here. So the sign is this -1/2 times a negative 4. And a negative times negative is positive, and half of 4 is 2. Now, I don't want you to change it to decimal. It says no decimal approximation. Exact value. That means no decimals. Keep that calculator away from it. Okay, now that was 2 points each on these up here and 2 on those, each part of those. This one, we didn't spend a lot of time talking about it, but we did talk a little about it. If I'm talking about sine of 90 degrees and cosine of theta, I'm going to make up an angle theta. Let's say theta is about this size. Then its cosine would be this long piece. Now if I go to 90 and back off theta, which is about this size I said, that would end up about there, which would be the same triangle, only now the long leg is here. And it said the sine of the long one, so that is the long one. Sine of this angle would be the long one, and it's positive, and it's the same length as the long one on this triangle. So we would have a value that's equal to this value. Both of them are positive, and we're subtracting them, so we end up with 0. And if you just told me 0, and some of you said this is sine of 90 minus sine of 0, and that does not work. You somehow came up with 0. I gave you 1 point. If you'd said 0 without showing me how you got it, I gave you 2 points. If you can show me some kind of reasoning on how this works, the sine of 90 minus theta is the same as the cosine of theta through this reasoning, and so we get cosine theta minus cosine theta, which is 0. Then you got 4 points. Number 5. We did a lot of these in the homework, and then I'm surprised that people messed up. Determine exact values. Now, it says the sine of phi is 5/9, and we know that sine squared of an angle, I'm changing it today, that should be phi, plus cosine squared of the same angle always equals 1. So if we use 5/9 for the sine and squared, we get 25/81 plus the cosine squared of the angle is 1. Then if I subtract 25/81s from 1, I get the cosine squared of phi equals 1 is 81/81 minus 25/81 would leave me 81 minus 5, 56/81. And then I have to take the square root. So I get the cosine of phi is equal, I take the square root of this, I get the square root of 56 and the square root of 81, which is 9, and taking the square root. There's 2 possibilities. And I have to decide which one I need. They said up here the cotangent's less than 0. It's negative. If the sine is positive and the cotangent's the ratio cosine to sine, and if the sine is positive, the cotangent must be, the cosine must be negative to make the cotangent negative. So I know that the cosine is negative square root of 56/9. Now some people said 4 goes into 56 and called this, it goes in there 14 times. So they called this negative square root of 4 to square root of 14/9. You didn't have to do that, but you could. fully for you. The tangent. The tangent is the sine over the cosine. So it'd be 5/9 over minus 2 square root of 14 over 9. The 9's cancel. And so we have a minus 5 over square root of 56. Or if you wish, minus 5 over 2 square roots of 14. And you can multiply by square root of 14 numerator and denominator if you wanted to rationalize. But that's good enough. Secant. Several people just wrote the reciprocal of 5/9. Secant's the reciprocal of cosine. So it's 9 over minus 2 square root of 14, or 9 over the negative square root of 56. Two, 6 points possible on that one. But you got to choose the right sign on that. Otherwise, you lose a point on everything because it messes all the signs up. Okay. I thought I did a lot of these. I thought you guys were following right along, and maybe you were. But when you did the test, it sure didn't convince me that you knew what was going on. So the amplitude is the absolute value of the thing times the function. So it's 2, not negative 2. Now the negative makes it flipped, and some people wrote that up here, and that's okay, but the amplitude is 2. Period. Cosine's normal period. And you divide it by what's times the x. And some people couldn't divide that well. If I needed to, I could take the 2 divided by 0.25, and I don't get half. I get 8. And so this comes out to be 8 pi for the period. Translations are slides. They're not stretches. So this is slid to the right pi over 2 and up 1. There are 2 translations on this one. So what's the 0.25 do? Well, it's less than 1. It's on the inside, so you would think it'd make it a quarter. 0.25 is a quarter. A quarter is wide, but everything is opposite, so it makes it 4 times stretched horizontally. 4 times as wide. I didn't spell that right. Horizontal. I'm missing something there. Okay, I'm going to not worry about that. This I said in class should have been negative pi over 2, and we said up here that moves it right pi over 2. The minus 2 is a vertical stretch by a factor of 2. It's twice as tall. Normally it goes from 1 to minus 1. Now it's 2 to minus 2. Twice as much. And flipped. And the plus 1 moves it up 1. Okay. So if it's up 1, I didn't have those up there. Okay, see those? A quarter makes it 4 times as wide. Pi over 2 moves it right pi over 2, stretches it vertically by 2, and then it's flipped because of the negative, and then it's up 1. So if it's up 1, the center line is now at 1. So I'm going to make that be 1, and that's 2 spaces, so I could better go 2 spaces to make 2, and another 2 spaces to make 3. And some people weren't careful about that and had spaces of 1 being 3 and then 2 and 5. You got to be, I'm not looking for precision here. Accuracy, you got to get it right. -3, -2, -1. It's important that you get these correct so you can read the graphs and you can make the graphs. The period is 8 pi, and I have to divide it in 4 parts. So I want to go out 4 separate sections here. So I'm going to make it 1 section, 2 sections, 3 sections, 4 sections, and I'm going to make that be 8 pi. Okay? So that would be 2 squares would be minus 2, 3, 4, and there's negative 8 pi. Get my units on there clear. And I have my center line. This is up 1, so I have a center line that's on 1. I have an amplitude that goes 2 above and below that. 2 above 1 is 3. And 2 below 1 is -1. Now, I'm drawing a cosine curve, which usually starts at the top, but it's flipped, so it's going to start on the bottom. And then it goes every quarter of a period. It will go from either the top to the middle to bottom to the middle to the center line. So 8 a quarter is here, then the top, then the middle, and then the bottom. And so it's looking like it's, and these should be rounded on the corners here, not sharp points. And then it's going back up. Some people made it go on down. It doesn't do that. It goes to the middle, to the top, to the middle, to the bottom. Now I need to do the phase shift of pi over 2 to the right. If this is 8 pi, that's 4 pi, that's 2 pi, that's pi. That much is a half a pi. So it's a half a square. So I got to move each one of these over a half square. So my final answer that I'm going to make a solid line. If you made the first one a solid, you're going to have to make a different color or a different pencil instead of ink or something. But I want to see it moved or an arrow pointing on it. This is the correct one. So there's the correct graph. I need to see the units. I need to see the quarters. I need to say the center line as the center line, where the maxes are correctly and above and below, depending on, and making sure your scale's even. Now, I know that's picky, but I think you can do it. A lot of people drew the tangent instead of the cotangent on number 7. Oh, by the way, 4 points, 2 points, 2 points, 2 points, 1 point, 1 point, 1 point, 1 point. Okay, back to 7. The tangent. Remember that on the unit circle, the tangent at 0 is 0. Goes as you go to the right, it goes from 0 to infinity, and then from negative infinity back to 0. But if you're doing cotangent, it's this line, and at 0, it's undefined. It's not there. It goes from undefined, from positive infinity to 0 as we're going around, and then to negative infinity. So it goes from positive infinity to 0 to negative infinity, starting at 0. All right. Now let's take a look at this. We've got an amplitude of 1/3. Some people were not careful about that. We got a center line down 2. And we've got a negative on the x, which leaves the period the same. Cotangent and tangent both have a period of pi, not 2 pi. The negative on the x inside the function flips it this way. So if the cotangent goes from positive to negative, looking at here, from positive to negative, and we flip it over, it's going to go from positive to negative going this way. So it's going to go like that. All right, so now let's mark it off. I have to have a third, so it would probably be smart to mark this off as 0. 3 squares up would be 1, and 3 more squares would be 2. And so that'd be 1/3, 2/3, 3/3, 4/3, 5/3, 6/3. Each square is a third. So I'm going down. I'd be down 3 for -1, down another 3 for -2, and my center line's at -2. And my amplitude is a third above and below that. So now, and my period is pi. And for cotangent, it starts at infinity, goes to infinity in pi. So I'm going to mark, I got to have pi out here, and I have to divide it in 4 spaces. So I'll just go 1, 2, 3, 4, and I'll call that pi. And it's undefined on 0 and at pi. And so it'd be undefined at -pi. So that's where the asymptotes are. Now I've clearly marked my units on here and on here. Now the cotangent at pi, a quarter of the way through its cycle, through its period, halfway through it, it's 0. So halfway through it, it's at 0, but the 0 is now on the center line, so that's here. And that would be also here. Now, normally it would go from here, wiggle and go down, but we flipped it over, so I'm going to go from here and wiggle and down. And at a quarter of the period, it's 1. So I'm going backwards here because it's flipped. At a quarter of the period, it's at a third. 1 on here times a third is a third. And at the next quarter, it's in the middle, and then at the next quarter, it's down a third. So I'm going to be looking for these clearly at 1/3 above the -2 and 1/3 below the -2. And once again here, if I go halfway between the asymptote and where it's the middle, halfway at the quarter, it's down a third, and halfway, it's up a third. Now, if you just try to type that in the calculator, you're going to have a hard time reading it and getting the units marked properly. You need to learn how to do this without just relying on the calculator. This problem, 6 points. Number 8. Okay. This goes from a +3 to a -1. That's 4 units. So the center line must be down 2 units. The center line must be at 1. So we got center line is y equal +1. Now, what is the amplitude? Well, it goes 2 above it and 2 below it. So the amplitude is 2. And several people said the period goes from here to there. But that's only half a wave. The rest of it, to get back up to where it can repeat, is going to be up here someplace. If this is half of it, and it looks like it's about 12 and a half, the whole period is going to be twice this, which is 25. Now, actually, what I did type in was something close to 25. 8 times pi, pi is 3.14 times 8, 8 pi is 25.1. So I used 8 pi to create this one, but if you use 25, to get the omega, it's the normal period divided by the actual period. So if you use 25, that's cool. So this would be the number you take times x in the equation. Or you could do 2 pi divided by 8 pi, which is 0.25. The pi's cancel, and 2 over 8 is 1/4. So you can use 1/4 also. So we're going to have a y equal. Don't forget the y equal when you do the retest, or I'll take a point off. We have a curve that's starting at the top and right on 0. Starting on the top, it's got an amplitude of 2, starts on the top, that's cosine. The number we take times the x is the normal period divided by the actual period, which is 0.25, 1/4, or if you want, 2 pi over 25 or pi over 12 and a half. Now I accepted pi over 12, but it should be 0.25 or 1/4. X, it's not shifted sideways at all, and the center line is 1 up. 6 points. This one. Some of you are not real careful about things here. Where's the bottoms of these? Take something straight and draw it. Does it hit at 1? Clearly not. Draw the tops of these. Does that hit at -1? Clearly not. It's at, if that's 1, that's a half, that's about 3/4. If that's -1 and -2, that's about -5/4. About a quarter down, below -1. So that means the center line is not 0. It has to be halfway between here. So from here to here is 2. So the center line must be 1 down from 3/4 is -1/4. Center line is y equals -1/4. The amplitude is 1 from 1/4 to 3/4 is 1. And if I put the center line in there and draw a curve that just touches here, it looks like this is exactly the asymptote, same distance apart there as there. So if I make a curve touch there, as many of you did, and then come down, cross here, and touch there, it starts on the center line. So this curve would be the sine, and these would be the reciprocal of the sine, which is cosecant. Got to have the y. Amplitude of 1. Period. Well, it's going to repeat by 4 pi. The normal period is 2 pi, so to get omega, it's the normal period divided by the actual period. Pi's cancel. 2/4 is 1/2 x. This is not shifted any because it starts right on the center line at 0, which is what the sine does. So that's what the cosecant will do. And then it's down 1/4. 6 points for each of those two. And then finally, 4 points for this last one. Now, I'll do it manually first. So, the minimum is 0. The maximum is 3.98. So that's close to 4 divided by 2. So that's going to be approximately 2 for the amplitude. The difference between the high and low times 2. So I'm going to have an amplitude of 2. And so the center line is going to be halfway, be 2 above the low or 2 below the high. So that's going to be, if the high is 4 and the low is 0, the center line is going to be y equal 2. So my equation is going to be y equals, I want a sine, so the amplitude is approximately 2 sine. To get the omega, it's the normal period. Sine's normal period is 2 pi divided by how long this takes to repeat. Well, it goes from 0 to 5, and then let's see here. It's not quite back to 0 at 5. It might be, it's getting close. 0.5 is somewhere around almost 1, so it's probably 5.5. If you used 5, I'd be okay with that. Just for our interest here, 2 pi divided by 5 is 1.25, 1.26. And if it was 2 pi divided by 5.5, we'd have 1.14. I'm going to go with that, 1.14. And there's going to be a phase shift, so I'm going to write x, not exactly in this form, and then I'm going to have to take the 1.4 and distribute it here, 1.14. Got to figure out this phase shift, but plus the center line, which I decided was about 2. So now, how much is this shifted? Well, the center line is, when does it get halfway from the bottom to the top? Well, it looks like the top's at 3, bottom's at 0, so probably this should have even been 6, 2 pi divided by 6, which is pi over 3. This might even have been a better number in here. And pi over 3, let's just figure that one out. Pi divided by 3 is 1.04. that probably would have been an even better number for here. But anything around 1.1, 1.2, 1.1, 1.0 I would have accepted in there. But how much does it shift it? Well, if it takes 3 to get to the top, it's going to take another 3 to get to the bottom, and so it'd take 1.5 to get to the middle. So the sign starts on the middle, so I need to shift this 1.5 to the right. So now, if I write it in this form, which would be really good to do, it would be y equals 2 sine, I'll use the 1.04, minus, and then I take the 1.04 times the 1.5, and I get 1.57 plus 2. Yeah. So now I'm going to do it, have the calculator do it, just so that you guys can see how to do that. So I'm going to push Stat, Edit, and I'll put in list 3 the times 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5, 5. There's those. Now, in list 4, I'm going to put in 0, 0.244, 0.919, 1.859, 2.832. Then over here, 3.602, 3.980, 3.873, 3.307, 2.422, 0.583. And now I push Stat, calculate the sine reg, and if you were doing in the older calculator, you would put I have it in list 3 for the x's and list 4, and I can have it do the put it in there. I don't know for sure what the period is, so I'm going to let it figure it out, and it's going to tell me that it thinks the A should be 2.008, close enough. This should be 1.10. That's kind of in between these, so I could have used this one or this one. It thinks the C should be minus 1.73. A little off there, but close enough. And over here is 2.05. If I'd used the 1.14 times 1.5, what would I have gotten? 1.14 times 1.5, I would have got 1.71, which was what they had, 1.73. So it would have been better to use this one according to the calculator, to match the calculator. But I would accept something that makes sense all the way through. Okay? All right.